Okay, our task here is to match each of these three functions, 4 to the x, 3 times 4 to the x, and 1/2 times 4 to the x, with their pictures on the left. We have to figure out which function goes with which picture. We know that every function or equation has its very own picture. We've seen probably parabolas. They're kind of like smiley faces. We've seen a lot of equations of lines. You may have seen equations of absolute values. They make V's. These are exponential functions. So when there's a variable, like here our variable is x, when it's up in the exponent, we call those exponential functions. So this is what they look like here. A good way to figure out which exponential function matches which picture is to pick a value for x and see what it spits out for y. So let's first start out with the this first equation. We're going to plug 0 in for x. Okay, we're going to do that on each of our equations, but we'll start out with this first one. So that means when x, remember it's on the horizontal axis, is 0, we want to figure out what coordinate it gives for y. And then we'll be able to see if it corresponds with the graph here, which graph it corresponds with. So let's try for the first one. When we plug 0 in for x, we get 4 to the 0 power, which is just equal to 1, because anything to the 0 power is 1. 4, 4,000, negative 22 million, 0.1, any of those numbers, you take them to the 0 power, and it always spits out 1. So we know that there's a point here that when x is 0, we got that y is 1. Okay, let's keep that knowledge with us. Now let's try for the next equation. We're plugging 0 in for x, but this time there's a 3 out in front, so we'll have to do 3 times 4 to the 0 power. Well, we know that this term right here is just equal to 1. And so this is the same thing as 3 times 1. And that just equals 1. That just equals 3, obviously. So in this, when we pick 0 for x, we get 3 for y. And our last equation, let's make a little space for it here. And make that a little smaller. When we plug in 0 for x, to the 0 power, there we go, we get 1/2 times 1 . That 1 is kind of ugly, isn't it? But we know what it says, which is equal to just 1/2. Okay, so here our final point, we plug 0 in for x, we get 1/2. Now we can come over here and compare. Okay, which graph has a point at 0, 1? So it looks like the black one here in the middle has a point at 0, 1. Right there. That is 0, 1. So that means 4 to the x is going to be this middle graph here, which is f of x. So we would match 4 to the x with f of x. Okay? Now we're going to check which of these graphs over here has a point at 0, 3. So if we go over 0 and we go up 3, that point there is 0, 3. And so we know that that corresponds with, this is g to the x right here. So this second graph matches our g to the x. And then finally we have a point at 0, 1/2, which is right here, you can see. That point is 0, 1/2. And that is our h of x graph, so we know that these correspond here. And we matched them. I hope that's helpful.